For this video, I'm going to explain how you can use the partial difference alternate algorithm for subtracting fractions. You can use this method because first you could start with subtracting the whole numbers. And if we start with 3, take away 2, that leaves us with 1. And then we can also go to the fractional parts, and then we can subtract those. That would be leaving us with -1/6. And then when you combine those at the end, it's 1 minus 1/6, and that leaves you with 5/6. So the difference for 3.5 minus 2 2/3 would be 5/6. Another option you could use that's an alternative method is counting up with fractions. For subtraction, if we use these same numbers, 3.5 minus 2 2/3, you would find, how do I get from 2 2/3 up to 3 wholes? That would be adding 1 more third. And then you can add, how would we get to 3.5? You would add 1 more half. That would get you to 3.5. So starting from 2 2/3 to get to 3.5, it would take 1/3 and 1/2. And then you can use the algorithm for adding fractions to find what is that difference then, which would be still 5/6. Both these methods work really well with mixed numbers, and the partial difference would not be as beneficial for a proper fraction that is not greater than 1, because there's really only one place value in that case. It's just your fraction. And if we're not turning them into decimals, then it really doesn't support much learning of the subtraction. But counting up with fractions could also work with improper fractions and proper fractions. You would still just have to count up in the same way we did down here with 1/3, or going from 2/3 up to 1/3. It would be the same process of finding how do you get from one fraction to the next fraction. You would still need to find common denominator.